Okay, we're going to jump into lesson 3.2 for the Math 2 prep here on graphing quadratics. This will be a continuation of our lesson from yesterday, which was 3.1, and we were graphing quadratic functions that did not have a b-value. Notice today's work is going to have a b-value, and that's just going to change things slightly for us. We still have the same steps here, so I'll give you a chance to pause the video and write those down. First, identify a, b, and c. Then find the axis of symmetry, find the vertex, find the y-intercept, and then here we have finding the x-intercepts, which is what we did not do yesterday. And notice it says to find the x-intercepts, we're going to use factoring. So that's the t-charts that we've done in the previous unit, and that's the part we didn't do yesterday. So we'll jump right into the first one here. And for this one, we'll start the same as we usually do by identifying a, b, and c. And so we've got a is equal to 1, remember, because that's an imaginary 1x squared there. Okay, and then we've got b is equal to 2, so we've got a b value here, and c is also equal to 1. All right, and then we can start to find the axis of symmetry, and to do that, we've got that formula. It's x equals negative b over 2a. And so then I just have to punch in my variables here. So that's going to be negative, and then the b value, which is 2, over 2 times a, which is 1. And I can evaluate that. That's going to be negative 2 over 2, which is negative 1, as I simplify it. And so I get an axis of symmetry at negative 1. And this is the first time that we've got a number other than 0 for my axis of symmetry. So x equals negative 1. And so I can go to the x-axis, identify negative 1, which is right there, and go ahead and draw my imaginary dotted line, okay, going through negative 1 here. And remember, that's the middle of my parabola there. And now I'll go ahead and find the vertex, because remember, the vertex is just a continuation of the axis of symmetry here. So we use what we found in the axis of symmetry, which was negative 1. And I'm going to take that negative 1, I'm going to plug it in for x in my original equation. And so it looks like this. Y equals, instead of x squared, I have negative 1 squared plus 2 times negative 1 and plus 1. So I just took my axis of symmetry number, which was negative 1, and punched in for x. And now I'll evaluate here. This is going to be 1 minus 2 plus 1, which gives me 0. And so that means that my vertex is going to be at negative 1, that's the x value from above, comma 0, that's the y value that I just found. And then I can go ahead and punch this in on my graph here. So that's at negative 1, 0. And that's going to actually put me right here on the x-axis this time. Okay, so we're on our axis of symmetry, of course, because the vertex will always be somewhere on that dotted line. And this one ends up on the x-axis, so that's a little bit different. All right, we'll go find the y-intercept. That's next in our steps here. Remember, you can always go back and reference the steps if you get lost. So we have the y-intercept, and remember the y-intercept is nice, quick, and easy because it's just the c value. So I just go to where my c value is, it's 1, so that means my y-intercept is 0, comma 1. And so I'll put that on the graph here, 0, 1. And this part's kind of nice. I'm going to go to my y-axis, put a point at 0, 1, because remember, since these parabolas are symmetric, if I have one that's 1 to the right, I also have a point that's going to be 1 to the left, and so I can label that other side there. All right, we've got enough to sketch our parabola, but remember, it's also asking me for the x-intercepts. So notice above, it says to find the x-intercepts, you're going to have to use some factoring. So I'm going to go ahead and take my equation here. All right, I'm going to set it equal to 0. So let's jot this down here. We've got the x-intercepts is what we're going to find here. So I'm going to take x squared plus 2x plus 1. I'm going to set it equal to 0. We'll always do that because we know that the y value at my x-intercepts, the y value has to be 0 because it hasn't gone up or down. It's just on the x-axis. And now I'm going to go ahead and use my factoring methods, which is to t-chart here. So x, and this one is going to be 1 and 1. And so my factors look like this, x plus 1, and in this case, another x plus 1, which of course we could write as x plus 1 squared. But what I actually want to do when I'm finding the x-intercepts is take each one of these factors and set them equal to 0 separately. And then I will be able to find what my x-intercepts are. So I'm going to set each one of these equal to 0. Of course, these are the same, so I don't really need to do it twice, okay, but just to get in good habits here. And then I will solve for x, so I get x equals, let's see, subtract 1 to the other side, so x equals -1, and x equals -1. And so we end up with our x-intercept at -1. And in this case, we have just one x-intercept at -1, right? We don't have to do it twice there because this one's the same for both of them, but you'll see oftentimes we'll get two different x-intercepts. So the x-intercept was -1, 0. And of course, in this case, right, that just ends up as the same point as my vertex, but it's not always going to be like that. All right, and now I'll finish off by sketching this parabola here. Going up, right, so it has a minimum value there, and we get this beautiful looking parabola. All right, if you didn't totally get it there, see if you can pick it up here. We'll go ahead and start the same as we always do. I'm going to start by identifying A, B, and C. So for this problem, we've got A is equal to -2, B is equal to -8, and C is also equal to -8. All right, so obviously for this one, we've got A is a negative number, so we should expect an upside down parabola. So let's jump into it here. The AOS, axis of symmetry, x equals -b over 2a. So for this problem, we're going to have negative and then my b value, which is also negative. So that's negative and then -8 over 2 times -2. And so then that turns into -8 is +8 over -4. And then I can simplify that into -2. And so I get an axis of symmetry at -2. So I have x equals -2. So then I'm going to go ahead and draw that axis of symmetry going through my x-axis at -2. All right, and remember that's the first part of the vertex, so we'll go ahead and find the rest of the vertex here. And remember, we do that by taking this -2 and punching it in for x in my original equation. And so it looks like this, y equals -2 times -2 squared minus 8 times -2 minus 8. All right, and we'll simplify here. Y equals, it's going to turn into -2 times 4 plus 16 minus 8. And of course, it's going to turn into -8 plus 16 minus 8. And we end up here with we end up here with 0. All right, and so for this one, we again end up with this vertex at -2, 0. And so we're going to see that's going to lie on my x-axis one more time. This is not always the case, but for these two problems, that's where it happened to be. So that was at -2, 0. And so we get this vertex right there. Okay, we'll go ahead and find the y-intercept here. Remember the y-intercept, always the quickest one. The y-intercept is just the c value. So that's just going to be 0, -8. And I can go ahead and punch that in on my graph here, down here at -8, and I'll zoom it in, because remember, if we have a point that is in this case, 2 units to the right, we have a matching point 2 units to the left of the axis of symmetry. So I'll go ahead and draw that matching point on the other side. Okay. And now we're going to go ahead and find the x-intercepts, and remember to do that, we're going to use factoring. So I'll go ahead and set this up. I'm going to take my original equation, which was -2x squared, negative 2x squared minus 8x minus 8. Set it equal to 0. And now I'm going to go ahead and factor this. And so remember, when we did our factoring, we look for a GCF first. So let's see, I'll go ahead and take out a negative 2 to start. And so that's going to look like this, negative 2, and then it's going to end up giving me x squared plus 4x plus 4 equals 0. And now I'm going to go ahead and t-chart here. I get x and 2 and 2. And so then I'm set up with this, negative 2 and x plus 2 and x plus 2. Okay. And that equals 0. And now anything that has an x with it, I'm going to go ahead and set it equal to 0 here. Remember, we did separate equations here, so I'm going to have x plus 2 equals 0 and another x plus 2 equals 0. These are the same, right? So I don't really need that second one. I can kind of get rid of that if I want, because it's just the same as the first one. Okay, and I'll go ahead and solve this. Subtract 2, and I get x equals negative 2. And so my x-intercept, in this case, is just 1. Oftentimes I'll have 2 different ones. My x-intercept here is going to be negative 2, 0. And notice we've already got that point right there. Okay, but I'll just put another dot there so we know that that's our x-intercept. Okay, at negative 2, 0. And now we can go ahead and sketch our graph. And it's going to look something like that. All right, we'll keep going here. It says identify the vertex for each function below. So that's just going to use, we're just going to go ahead and use our first step is finding the axis of symmetry, and then we'll plug it back in. So I need to find A, which is 3, B, which is 6, and C, which is negative 7. And now I'm going to start by finding the axis of symmetry. X equals negative B over 2A. That's going to be negative 6 over 2 times 3, which is going to give me a negative 1. And so that's the first part of the vertex, also known as the axis of symmetry. I'm going to take that number, I'm going to plug it in for x in my equation, and that'll allow me to find the y coordinate. So I get y equals 3 times negative 1 squared plus 6 times negative 1 minus 7. And we'll evaluate here. Y equals, let's see, that's going to be 3 minus 6 minus 7. And that's going to give me a grand total of negative 10. And so then my vertex for this point is going to be the x-coordinate is negative 1. The y-coordinate is negative 10. All right, sliding over here. Function 2, they just give me a picture, so I can just pick off the vertex, which is right there, and that looks like it's at 1, negative 3. So that's at 1, negative 3, so not much work there. And then we slide over to the last one, okay, and it says we've got A and B and C. And so then I can start by finding the axis of symmetry, negative B, which is negative 8, over 2A, that's 2 times 4. That's negative 8 over 8, which is negative 1. And now I take that and I plug it back in. So I get y equals 4, and then negative 1 squared plus 8 times negative 1 plus 1. And I'll evaluate here. That's going to give me 4 minus 8 plus 1. So I get a grand total of negative 3. And so my vertex ends up being negative 1. That was the x-coordinate. Negative 3, that's the y-coordinate. And I get my 3 vertices here that it's asking me for. It says, which function above have the same axis of symmetry? And so for this one, that's going to be function 1 and function 3, because remember the axis of symmetry is the x-coordinate there, and those have the same axis of symmetry. So I'm going to put 1 and 3. That's functions 1 and 3. Okay, and then it says which function above has the lowest minimum value. Okay, and so that's going to be the lowest y coordinate. So I'm looking at my y coordinates here, -10, -3, and -3. And so the lowest y value I have is -10, and that's going to be my that's going to be function 1. That's going to be my lowest minimum value. All right, thanks for watching.